The ocean. It covers more than 70% of our planet's surface, a vast, seemingly endless expanse of blue. From space, it defines our world, a shimmering sphere of life. Yet, for all its familiarity, its depths remain one of the last great wildernesses. We have explored more of the surface of the moon than we have the deepest trenches of our own seas. It is a realm of profound mystery, where sunlight struggles to penetrate, and honestly, the pressures are immense. Down here, in the perpetual twilight, life takes on forms both beautiful and bizarre, and the very laws of our terrestrial world seem to, well, warp and bend. But it is not just the creatures that inhabit this world that are extraordinary. The ocean itself is a dynamic, powerful force, capable of phenomena so strange they border on the fantastical. It can conjure ghostly lights on the horizon, create deadly, swirling traps for the unwary, and hide geological formations that defy easy explanation. These are not tales from mythology, but real documented events that continue to puzzle and captivate scientists and explorers alike. They are reminders that even in our modern age of technology and information, there are still corners of our world that hold their secrets close. Join me as we journey into these enigmatic waters. We will investigate a strange, disc-like anomaly resting on the seabed, a discovery that has sparked theories of ancient technology and otherworldly visitors. We will explore the raw, untamable power of the ocean, from colossal whirlpools that have terrified mariners for centuries to waves that form impossible, dangerous grids upon the surface. We will witness fleeting moments of natural art and uncover the hidden dangers that lurk just beneath the waves. This is the story of the ocean's strangest secrets. In the summer of 2011, a team of Swedish oceanographers, the Ocean X team, were searching for sunken treasures in the Baltic Sea. Using side-scan sonar, they were mapping the seabed when an astonishing image appeared on their screens. There, at a depth of nearly 300 feet, was a massive, perfectly circular object, some 200 feet in diameter. It looked uncannily like a crashed flying saucer, complete with features that resembled ramps, stairways, and other artificial structures. It quickly became known as the Baltic Sea anomaly, and it ignited a firestorm of speculation that continues to this day. What could this strange formation possibly be? The theories range from the mundane to the truly extraordinary. Some geologists propose it is a natural rock formation, a glacial deposit shaped by the immense pressures of the last ice age. Others, however, are not so convinced. The object's strange symmetry and the long runway-like track behind it suggest something else. Divers who approached the object reported that their electronic equipment, including satellite phones and cameras, mysteriously failed within its vicinity. This has led to more sensational theories. Is it a remnant of a lost ancient civilization? A secret Nazi anti-submarine weapon from the Second World War? Or, as its shape so strongly suggests, the wreckage of an extraterrestrial spacecraft that crashed into the sea thousands of years ago? For centuries, sailors have whispered tales of monstrous whirlpools, powerful enough to swallow ships whole. These are not mere legends, they are maelstroms. The most famous, the Maelstrom, churns in the Lofoten Islands off the coast of Norway. It is a place where powerful tidal currents are forced through a narrow strait, creating a vortex of terrifying force. Viking sagas spoke of it with dread, a gateway to the underworld from which there was no return. Even the great author Edgar Allan Poe immortalized its horror in his story, A Descent into the Maelstrom, describing a vortex that could pull vessels into its gaping maw. Though modern ships are far more powerful than the Viking longboats or wooden sailing ships of old, the danger has not entirely vanished. The Maelstrom and other powerful maelstroms, like the Corryvreckan in Scotland, can still generate surface speeds exceeding 20 knots and create chaotic, unpredictable waves that can capsize smaller vessels. The immense power of the swirling water can overwhelm steering and propulsion, leaving a boat at the mercy of the current. For kayakers, small fishing boats, and even experienced sailors caught unaware, these natural phenomena remain a potent and humbling reminder of the ocean's raw, untamable power. The term black hole typically conjures images of cosmic phenomena, celestial bodies with gravity so strong that not even light can escape. Yet, our own oceans harbor a remarkably similar feature: massive swirling vortices, or eddies, that behave in much the same way. These are not the surface whirlpools of myth, but colossal, rotating bodies of water that can span over 90 miles in diameter. They are so tightly bound that nothing caught within them can easily get out. Water, plastic debris, nutrients, and even living organisms become trapped, spiraling within their confines for months or even years. These ocean eddies are the aquatic equivalent of black holes. Their mathematical structure is identical to that of their cosmic counterparts. They are incredibly difficult to detect from the surface, as they often exist deep beneath the waves, their effects subtle and hidden. Scientists use satellite altimetry to track the minute changes in sea surface height that betray the presence of these giants below. These underwater black holes play a crucial role in the ocean's ecosystem, transporting vast quantities of warm or cold water across basins, profoundly influencing weather patterns and the distribution of marine life, locking away secrets in their ceaseless, silent spin. It is one of nature's most elusive and magical displays, a phenomenon so fleeting that for centuries, many believed it was just a sailor's myth. It is known as the green flash. Now, this is not a storm or some strange light from the deep, but rather a rare optical event that occurs for just a second or two at the precise moment of sunrise or sunset. As the very last sliver of the sun's disk dips below a clear, unobstructed horizon, or the first sliver appears, it can momentarily flare with a brilliant emerald green light. It's honestly a breathtaking sight, a final vibrant wink from the sun. This beautiful spectacle is a product of atmospheric refraction. As sunlight passes through the Earth's atmosphere, it is bent, much like light passing through a prism. The atmosphere separates the light into its constituent colors, with the shorter wavelength colors, like blue and green, being bent more than the longer wavelength colors, like red and orange. When conditions are perfect, typically a very clear, stable atmosphere and a distant horizon, such as one finds at sea, the red and orange light from the setting sun is obscured by the curve of the Earth first, allowing the green light to be visible for a brief, dazzling moment before it too disappears. Imagine, just for a moment, looking out at the ocean and seeing the familiar blue waters transformed into a murky, ominous red, as if the sea itself were bleeding. This startling phenomenon is known as a red tide. It is not, in fact, a tide at all, and the water is not blood. It is an algal bloom, a sudden explosive population growth of microscopic algae. While many such blooms are harmless, some species, like Carenia brevis in the Gulf of Mexico, produce powerful neurotoxins. When these organisms multiply into the billions, they release vast quantities of these toxins into the water and the air. For marine life, a red tide can be an apocalypse. The toxins paralyze the central nervous systems of fish, leading to massive fish kills that can leave beaches littered with the dead for miles. For humans, the danger is also very real. The toxins can become aerosolized by the surf, and inhaling this sea spray can cause respiratory irritation, coughing, and sneezing, especially for those with asthma. Consuming shellfish that have filtered the toxic algae can lead to neurotoxic shellfish poisoning, a serious illness that can cause severe gastrointestinal and neurological symptoms. A red tide is a stark warning from the ocean, a sign of an ecosystem thrown dangerously out of balance. Our planet's most extensive chains of volcanoes are not on land, but hidden beneath the waves. Submarine volcanoes line the mid-ocean ridges, silently and constantly reshaping the floor of the sea. While many are in the crushing depths of the abyss, some lie in shallower waters, posing a hidden and unpredictable threat. An eruption can occur with little to no warning, releasing enormous quantities of superheated gas, ash, and rock. The water temperature can flash boil, creating a violent explosion capable of sinking ships that happen to be passing overhead. The sea can appear to boil, churning with pumice and discolored with volcanic chemicals. These underwater eruptions are also creators. When the molten lava meets the cold seawater, it shatters into tiny fragments of volcanic glass. Over time, currents and waves carry these fragments to shore, depositing them to form stunning and otherworldly black sand beaches like those found in Hawaii, Iceland, and the Canary Islands. The very sand beneath one's feet is a testament to the immense, fiery power that lurks just offshore. These volcanoes are a fundamental force of planetary construction and destruction, a reminder that the seemingly tranquil surface of the sea can conceal geological violence of an unimaginable scale. The surface of the ocean can sometimes form a pattern so strange and unnatural, it looks like a glitch in reality. This is the phenomenon of cross seas, or a square sea. It manifests as a grid-like or checkerboard pattern of waves, where two distinct wave systems, traveling from different directions, intersect. This typically occurs when waves from a distant weather system continue to travel in one direction, while local winds begin to generate a new set of waves moving in another. The result is a deeply unsettling and remarkably dangerous seascape. While it may look mesmerizing from a high vantage point, being caught in cross seas in a boat or as a swimmer is exceptionally risky. The intersecting wave crests create steep, pyramidal peaks and deep, abrupt troughs. This chaotic state makes a vessel incredibly unstable. A boat that can easily ride up and down a single wave train can be hit from multiple directions at once by these intersecting waves, causing it to roll violently and increasing the risk of capsizing. For swimmers, the powerful and unpredictable currents created by this interference pattern can easily lead to exhaustion and drowning. It is a rare but potent example of how simple wave mechanics can combine to create a uniquely hazardous environment. On a windy day at the coast, it is a common sight, white, frothy foam accumulating along the shoreline, pushed and pulled by the waves. This is sea foam, and in most cases, it is a perfectly natural and harmless occurrence. It forms when the ocean is agitated by wind and waves, much like whipping egg whites. Dissolved organic matter in the seawater, fats, proteins, and other compounds derived from decaying algae and marine life, act as surfactants, or foaming agents. These compounds reduce the surface tension of the water, allowing bubbles to form and persist, creating the foam we see. However, under specific circumstances, this seemingly innocent foam can become a vessel for danger. When large, harmful algal blooms, like the red tides we discussed, die off and decompose, their toxins can become concentrated in the sea foam. The wind can then whip this toxic foam into the air, carrying the harmful compounds much further inland than sea spray alone. Inhaling this aerosolized foam can cause more severe respiratory issues than the algal bloom itself. In places like Yamba, Australia, massive foam days have occurred, burying streets and houses near the coast in enormous sudsy drifts that, while spectacular, can hide a cocktail of unseen toxins. In certain parts of the world, rivers can, for a brief and dramatic period, flow backwards. This is not a trick of the eye, but a powerful natural event known as a tidal bore. It occurs in areas with a large tidal range, where the incoming high tide is funneled into a shallow, narrowing river or estuary. The front of the incoming tide forms a wave, or a series of waves, that travels up the river against its natural current. These bores can range from a few inches in height to towering walls of water, like the Chantang River bore in China, which can reach up to 30 feet high and travel at 25 miles per hour. The arrival of a tidal bore is often accompanied by a loud roaring sound, a warning of the immense power about to be unleashed. While they are a spectacular sight and attract surfers and thrill seekers in places like the River Severn in the UK or the Turnagain Arm in Alaska, they are inherently hazardous. The force of the wave can easily capsize boats moored in the river and is extremely dangerous for anyone caught unaware in the water. The powerful currents and turbulence that follow the main wave can persist for a significant time, rearranging the riverbed and posing a serious risk to riverside structures and navigation. The ocean can be a place of serene beauty, but its mood can change with terrifying speed. Nature, however, often provides warning signs before unleashing its most violent fury, such as lightning and tornadoes. Before a lightning strike over water, you might notice your hair standing on end, a metallic taste in your mouth, or hear a faint buzzing or crackling sound from metal objects, like fishing rods or boat rigging. These are signs of a strong static charge building up, a final, urgent warning to seek shelter immediately. A waterspout, which is a tornado over water, also has its precursors. Watch for a dark spot on the water's surface, a sudden change in wind, or a circular pattern of spray being kicked up. If these signs appear, action must be immediate. When lightning threatens, the worst place to be is in the open water or on a beach. Get to land and find a substantial building or a hard-topped vehicle. If caught on a boat, stay low in the cabin, away from metal components and the mast. For waterspouts, the advice is simpler. Get out of its path. These vortices are unpredictable. While they are often weaker than their land-based counterparts, they can easily capsize a boat or throw a person into the air. Heeding these natural warnings is not cowardice, it is the wisdom of survival, a skill practiced by mariners for millennia. Our journey through the ocean's enigmas comes to a close, but the mysteries themselves endure. From the silent, geometric puzzle of the Baltic Sea anomaly to the fleeting emerald beauty of the green flash, the sea constantly challenges our understanding. It demonstrates a power that can reverse rivers and a subtlety that can concentrate invisible poisons into seemingly harmless foam. These phenomena are not just curiosities. They are integral parts of a complex, interconnected system that governs our planet's climate, chemistry, and life. They are a profound illustration of the forces that have shaped our world over eons. The ocean reminds us that there is still so much to learn, so much to discover. It holds the history of our planet in its sediments and the potential for future discoveries in its unexplored depths. Every strange wave pattern, every unusual light, every unexplained sonar reading is a question waiting to be answered, an invitation to look deeper and to understand more. The fear and awe it inspires in us, the same feelings our ancestors felt gazing out from the shore, are what drive us to continue exploring, to chart the unknown, and to appreciate the sheer, magnificent wonder of it all. As we continue to probe its secrets, we must also remember our responsibility to protect this vital wilderness. The health of the ocean is inextricably linked to the health of our planet and ourselves. The red tides, the debris caught in giant eddies, these are also signs, warnings of the impact we are having. The greatest mystery of all may not be what lies in the deepest trench, but whether we can learn to live in balance with the vast, powerful, and mysterious world of water that gives us life.